The next problem says the following. A 6 kilo box is held raised by two ropes that form at 30 degrees angles with the vertical. An external force F acts vertically, keyword is vertically, downwards on the box. Then the force exerted by each of the two ropes is denoted by T. A force diagram showing the four forces that act on the box in equilibrium is shown in the figure. So the figure that represents what we just read is right here. So the question is, we're giving us also that the magnitude of force F is 410 newtons. So we have to find the magnitude of the force T being closest to one of these values. So we're gonna have to find the forces. Sum all the forces in the y direction is represented by mass times acceleration of y. So we have two forces, one going this way and the other one going to the right and upward. So it's going to be t cosine 30 plus t cosine 30 minus the weight, which is located right here, is denoted as mg, and minus the force, which is represented right here. All is going to be equal to 0 as they're giving us this information right here. The box is in equilibrium. Therefore, we just do some algebra. We pass the mg and the f to the other side as positive. Then we plug in the values. The mass is 6 kilos times 10, which is the gravity, plus the force that they also gave us for 10 newtons. We add it up right here. We continue solving for t, and we end up with a value of 271 newtons. And that should be our answer. In the next problem, we have a plastic ball in a liquid that is acted upon by its weight and by a buoyant force. We know that the weight is 2.6 newtons and that the buoyant force has a magnitude of 4.4 newtons, which is acting vertically upward. It says at a certain point the ball has a zero velocity, and at that exact moment the external force acting on the ball has an acceleration of 3 meters per second squared in the downward position. So the question is, find the external force and its direction. So we just drew a representation of what was written over here. So based on the Newton's law, the sum of all the forces equals mass by acceleration. We encounter the weight, which is going down, and the acceleration is going down as well. That makes the weight be positive, and then plus the external force, what we're trying to find, minus the buoyant force, which in this case is going upwards, based on the question, all equals ma. Therefore, we just do some algebra. We put in the values, we move everything to the right side so we can find the external force, and we end up with 2.60 newtons going in the downwards direction. We saw,